Welcome to another warm-up. This one clearly all about L'Hopital's rule. Lots of different ways and little quirks to it. Here are just a couple of reminders / problems / refreshers. So give it a try. Okay, hopefully you paused the video and gave these a try. Let's work through them. This first one, always got to check, is it in indeterminate form? If I plug in a 0, I get 1 minus 1 is 0. And on bottom I get a 0. That is an indeterminate form. I am allowed to use L'Hopital's rule. Always nice to let your reader know, hey, I'm about to do something kind of weird here. Let's let theta go to 0 still. The derivative of the top is 0 minus negative sign, so minus becomes a plus, sine of theta, all over. Derivative of theta is 1. Great. Now we have to check what happens if I plug in on top. I get a 0. On bottom, I get a 1. Please do not do L'Hopital's rule again. You'll be in a lot of trouble here. That is not indeterminate form. That is our good friend 0 over 1, also known as 0. How nice is that? Thanks, Bernoulli, for selling that to L'Hopital. Moving on. This, well, is this nice? I'm going to negative infinity, so this is going to negative infinity. E to the negative infinity is, do you know? You gotta know. You gotta know what happens on that far left side of the graph for e to the x. This thing is going to 0. What is negative infinity times 0? I really don't know. It's going to be different depending on how fast it's going to 0 and how fast it's going to infinity. The general rule is when x and e to the x fight, e to the x is going to win. But let's see why. First thing I gotta do is try to transform this into some kind of indeterminate form. And there's two ways you might try to do this. You could write this as e to the x over x to the negative 1, or you could write this as x over e to the negative x. And this is going to be your winner. If you don't believe me, try it the other way. What's nice about this is that the thing on top gets simpler. And that's your rule of thumb for what should stay on top, is what is going to get simpler if it stays on top. So if there's a natural log, we like the derivative of that a lot. We like the derivative of x a lot as well. So now, does this look like it is an indeterminate form? This is going to negative infinity. This is going to e to the negative infinity. It's e to the positive infinity, so this is just going to be infinity. Put those together, we get infinity over infinity. That is indeterminate. I like it a lot. Here I go. Keep that limit around. You don't get to get rid of it. I'm still in a limit. Derivative of the top is 1. Derivative of the bottom is negative e to the negative x. Thanks, chain rule. Okay, now that we have that, we get to plug in again, but now it plugs in much nicer. So the top stays 1, and the bottom goes to e to the negative infinity is positive infinity, but then there's the negative outside. So negative infinity doesn't really matter. 1 over a giant number, whether it is positive or negative, is going to go to 0. And that's what we see again, is that this e term won out over the x term. Okay, friendly reminder, serious reminder, you don't get to forget your quotient rule. You need to know the difference between using L'Hopital's rule in a limit when you're in indeterminate form, where it's just the derivative of the top over the derivative of the bottom, versus taking the derivative of a fraction where you need to use the quotient rule. A little bit more complicated. Okay, last one. Plugging in here, I get x is going to pi, and y minus cosine is going to negative 2. This doesn't look indeterminate at all. Please just remember you have to check. This was just a are you checking kind of a question. This function is continuous at pi. Right? It is a fraction of two functions that are both continuous at pi, where the denominator is not 0, so we are good to go. We just plug in. Done and done. Okay, so you do have to check. Don't use L'Hopital's rule where you're not supposed to. Nice refresher. The other thing that you might need a little bit of refresher on is what happens when there are exponents, like our old friend 1 plus 1 over n to the n, as n goes to infinity was our great example of that. So don't forget that these also usually need some practice. Taking a natural log first would be the thing that maybe we didn't cover in this warm-up, but good to practice. All right, see you again soon.